The solid part of the Earth, or lithosphere, is composed of a variety of kinds of rocks. Much more is known about those exposed to view on continents than those that floor the ocean basins. There are many different kinds of continental rocks, but two types make up most of the continental crust. They are basalt and granite. This laboratory program will begin with these two rocks and their mineral components. Minerals such as biotite tend to split into thin sheets, exhibiting a physical property of minerals called cleavage. Biotite, muscovite, and other minerals which cleave in just one direction are said to have one direction of cleavage. Other minerals cleave in more than one direction, so have more than one direction of cleavage. For example, calcite breaks readily into rhomb-shaped fragments bounded by 6 shiny faces. Each face is a cleavage plane. Cleavage planes on opposite sides of the cleavage fragment are parallel to one another. Cleavage fragments on this mineral are bounded by 3 sets of cleavage planes, and the mineral has 3 directions of cleavage. Note that between cleavage faces, there are surfaces within the mineral along which it will break. This mineral, halite, also breaks into cleavage fragments with 6 faces and has 3 directions of cleavage. However, it is clearly not the same shape as calcite, because the 3 sets of planes intersect each other at different angles in the 2 minerals. The angle between adjacent cleavage planes can be measured with a simple instrument called a goniometer. Measurement with a goniometer shows that the cleavage planes of this mineral intersect at 90 degrees. The angle between the cleavage planes of this mineral is about 75 degrees. Although both minerals have 3 directions of cleavage, we can distinguish between them by measuring the angles between cleavage planes. This mineral exhibits irregular breakage, which does not follow cleavage planes. This property is called fracture. There are also 2 directions of cleavage which intersect at 90 degrees. In review, some minerals break readily along smooth surfaces called cleavage planes. 2 of the ways we can distinguish between these minerals are by the number of sets of parallel planes and by the angle at which the sets of planes intersect. Most minerals are capable of scratching some other minerals. Most, too, can be scratched by some others. If minerals are grouped by their ability or inability to scratch quartz, for example, it is found that most cannot. Those are called softer than quartz. The few that scratch quartz are called harder than quartz. Performing the same test for all minerals, the relative hardness of each one can eventually be determined. Using this method, geologists have devised a scale of hardness to which any mineral can be compared. The hardest mineral, diamond, is number 10 on the scale. Talc, the softest, is assigned number 1. Others are given values 2 through 9. To determine the hardness of the mineral pyrite, we try to scratch it with each of the minerals on the scale. The first mineral that will scratch it is quartz, so it must be softer than quartz. It will not scratch quartz or orthoclase, but it will scratch the others. It is softer than quartz and harder than apatite, or about the same hardness as orthoclase. Pyrite is said to have a hardness of 6.